Okay, guys, so we're still talking about functions. Today we're going to be talking about composition of functions, okay? And what this word composition means, okay, it basically means that we are going to be plugging a function into another function.
And these classrooms are not made for this much computers.
Okay, so that's all that composition of functions means. It means instead of just taking a single number and plugging it into a function, okay, today we're actually going to be taking functions and plugging them into a function. Okay, so let's go ahead and just review for numbers 1 and 2. It's asking us to perform the indicated operation. Okay, and this is always so, there we go. All right, so let's look at number 1. Okay, this is where we're given two functions. Okay, and it's asking us to perform the operation. What is the operation? Addition, subtraction, multiplication, division.
Subtraction.
We're subtracting these guys. Okay, remember, with subtraction, the order matters. The order does matter. So this time you need to take G first and then subtract F. Okay, so my G is the one on top. 2x cubed plus 4x. And we're subtracting my entire f of x function, x minus 3. Okay, the reason I put parentheses around the entire f of x function is because we're subtracting that whole piece. Okay, we're not just subtracting the x, we're not just subtracting the negative 3, we're subtracting the whole piece. Okay, so remind me, you guys, what is that rule that when we're subtracting, what happens to the signs after it? Does it stay the same or does it change? They change, right? Okay, so my first two terms, they're just going to stay the same. So I have 2x cubed plus 4x. But because of that subtraction, now the signs after are going to change. Meaning positive x changes to negative x. Negative 3 changes to positive 3. And now we got rid of those parentheses. Okay, so now it just becomes an expression where we need to combine like terms. So where are my like terms that I can combine here to simplify it?
2x and 4x.
Not quite. 2x has, which one, Bella?
X and 4x.
Good job. Okay, I cannot combine the 2x because that one's to the power of 3. I can only combine the 4x and negative 1x, right? Same variable, same power. Okay, well tell me, you guys, what is 4 minus 1 going to give me?
0. 1.
4 minus 1?
2.
3. Okay, so this 2x cubed stays 2x cubed in front. Those two middle terms just change to positive 3x and my plus 3 on the end. And there we go. Okay, and number 2 is way too easy for you guys, so I'm actually going to change it, make it a little harder. Instead of adding these two, now what are we doing?
Multiply.
We're going to multiply them. Okay, so whenever you see that little multiplication dot, now we are multiplying these two functions. Yes, I'm challenging you guys. Okay, so this means I'm going to take my first h of x function, negative 2x minus 5, and I'm multiplying it to my g of x function, 2x cubed plus 3. Okay, what does this look like? What's the method we talked about, learned about last year? What is it? FOIL, beautiful. Okay, I'm not going to write out the acronym FOIL, but you guys get the idea. It basically just means the swooshy method, meaning we need to take each of these terms, multiply it to each of those terms. So let's start with negative 2x. I need to take this term, multiply it to both of those guys. Okay, well, what am I going to get with negative 2x times positive 2x cubed? Just think, what is negative 2 times positive 2, first of all? Negative 4. Then I had 1x being multiplied to 3 x's. How many x's do I have total? 1 being multiplied to 3.
Oh, 3.
Close. Exponent rules tells us 4. Now it's x to the 4th. Okay, well now I need to take negative 2x times 3. What am I going to get with that guy? Negative 2x times 3.
6.
Beautiful. Positive or negative 6 though?
Positive. Negative.
Negative 6. Negative 6x. Great job. There's our first two terms. Now I just need to take my negative 5. Do the same thing. Multiply that guy to both of those terms. Negative 5 times positive 2x cubed.
Negative 10.
Negative 10x to the power of
Cubed.
cubed. Beautiful.
So 10x to the fourth power.
Ooh, not quite. Okay, my last one. What's negative 5 times 3?
15.
Positive 15?
Negative 15.
Negative 15.
Everything's a negative.
Okay, so, yeah, everything is a negative. Okay, so again, it's just an expression where now we need to see if we can combine like terms. Can we?
No.
No, we actually can't, right? I see some x's, but one's to the 4th power, one's to the 1st power, and one's to the 3rd power. Okay, so technically this is a right answer. But you guys are upper level math now. So we're going to write it in what they call descending order, meaning start with your highest function and go down. So negative 4x to the 4th is still going to be in front, right? That's the highest power, highest degree. But then my negative 10x cubed comes next. That's my next highest degree. Which one's going to come next?
6.
Good.
6. Negative 6x.
Good job. So then my negative 6x, my power of 1, and negative 15 without any x's is on the end.
But wouldn't 15 be after 10, a bigger number?
Ooh, I love that. Okay, we're not looking at the numbers. We're not looking at the coefficients. We're looking at their powers. 4, 3, 1, 0. Great question. Love it. Okay, show me a fist of 5 on adding, subtracting, multiplying, dividing functions. You have two functions, you're just going to get another function. Cool, I like it. Okay, well now 3 through 10, we're asked to evaluate these functions. Okay, so for numbers 3 through 6, we're just given a number. We're given a function. We need to take that number and replace the, it looks like x's with that number we're given. Okay, so what am I replacing the x's with?
Negative 6.
Beautiful. Okay, it was w to the x, now it's w to the negative 6, which means I'm going to take that negative 6, plug it in everywhere I see an x. Okay, so now this becomes negative 3 times negative 6 squared minus 1. Punch it into your calculator or follow the order of operations and get your answer. Okay, I need to take care of exponents before I can multiply anything. What is negative 6 squared?
6.
Negative-
12.
Negative 6 times negative 6.
Oh, positive 12. No.
Negative 36.
Close? Positive 36. So now I have negative 3 times positive 36, and then I'll subtract the 1 at the very end. Okay, but again, still got to follow PEMDAS. Now I need to multiply before I can subtract. Okay, this is where I'm going to use a calculator here. What is negative 3 times 36?
Negative 3 times.
Mm-hmm. You guys are just...
Negative 108.
Thank you, Kaylee. So now we have negative 108. Subtract one more. What is my final answer?
Subtract 1,
Mhm.
negative 107.
Very close.
Oh, negative 109.
There we go. Beautiful. Just take that number, plug it in, replace. Okay, number 4. What are we plugging in?
7.
7. Okay, which means we are going to take that 7. This time we're replacing the a in my function. Negative 2 times 7 plus 5. No powers to take care of, so we can go straight into multiplying. What is negative 2 times 7?
Negative 14.
Negative 14. And my final answer is going to be negative 14 plus 5. What am I going to get?
-9.
Negative 9. Boom. Okay, not too bad, not too bad. In fact, I want you guys to try number 5 on your own. Okay, I'm gonna give you about 30 to 60 seconds, so a minute tops. Try number 5 on your own, then we'll compare answers. Ready, set, go. Just try it. There's absolutely no consequence for getting it wrong. Ooh, I like this one. This is like a challenge one. If you get stuck, don't worry about it. When in doubt, punch it into your calculator. See what it gives you. Okay, let's take about 5 more seconds, even if you're not quite done. Okay, notice, I don't have the final answer yet because I want to work through this one with you guys. This one's a fun one. Okay, so all I did here was take my -1, replace my ends with it. So now I have -1 cubed minus 2 minus a -1. Okay, well, let's take care of this first little piece right here, you guys. What is -1 cubed? Now think about this. -1 times -1 times another -1. What's that give me? Not quite. Okay, let's do it together. What's -1? -1 times -1 is what? +1. What's +1 times another -1?
-1.
-1, okay. Yep, -1, right there. Okay, now remind me, you guys, this -2 in the middle, we'll take care of him in a minute. But what happens when I have this double negative sign there? What does it turn into?
Positive.
Great job. So now what I have is -1 minus 2 plus 1. You could punch that whole thing into a calculator. What is your final answer? Connor? It's just -2. Or you can think, oh, these guys cancel each other out. All I'm left with is -2. Booyah. Ooh, I liked that one. That one was a fun one.
That was definitely
Fun, super fun. Okay, last one where we're just plugging in a number. What am I replacing my t with? -9. Okay, so I'm gonna take my -9, plug it into my t. So now I have -9 squared minus 4. Let's take care of our exponent before we subtract. Tell me, what is -9?
Positive 81.
Beautiful. Okay, what is 81 minus 4?
77.
Beautiful. Look how fast. Boom. That's all we're doing. Yes. Yes, you may. Okay, you guys, on our last 4, the difference between these guys, it's kind of the same thing, but the difference is we are not plugging in just a single number anymore. I'm still given a function, p of x, where I have some x's in there, but this time, what am I replacing my x's with?
-1x.
Ooh, close. 1 minus x. So it's actually this like little mini function that we're plugging into these spots. Okay, so I need to take 1 minus x and plug it everywhere I see an x here. This might get a little messy looking. That's okay. The rules don't change, it just gets a little bit messier. Okay, so here's what I have. Instead of x cubed, I now have my piece, 1 minus x cubed, minus 2 times x, well now it is minus 2 times 1 minus x. Okay, and here's what I'm going to tell you guys. We could multiply this out 3 times, okay, but for the sake of time, I'm going to go ahead and just leave this as 1 minus x cubed. It's okay, we don't feel like it today, okay? That's totally fine. Okay, but let's not be super lazy. I know I can distribute these guys. I need to take this -2, multiply it to everything inside. What's -2 times 1 gonna give me?
-2.
-2. What's -2 times -x going to give me?
-2x.
Are you sure negative?
Oh, positive.
Plus 2x. Now, is this the entire simplified version of this function? Nah, but we're just gonna leave it, okay? It's fine. Okay, the difference on these guys, your answer is not a number anymore. It's a new function, right? We took a little function, we plugged it into a function, we get a function. Okay, cool. Alrighty, let's go ahead, look at number 8. What am I replacing my x with? 2x. Okay, so we're gonna take that 2x, and we're gonna plug it in everywhere we see an x. Just one spot right there. So now I have 3 times x. Well, now it's 3 times 2x. Replace that x with 2x. Plus 4. Cool. Okay, well, all I really need to do here is just multiply. This one we don't need to be super lazy. This one's pretty simple. What's 3 times 2x, Kaylee?
6x.
6x. Can I combine these like terms,
No.
or is it simplified?
It's simplified.
It's simplified. I cannot combine any like terms. I can't distribute anything. So we are done. Okay, on numbers 9 and 10, I'm going to change it up just a little bit. Okay, so everybody copy down what I'm copying down, because this is how you might see it, or not might, you will see it on your assignment written like this. Okay, so I'm gonna take k of t. What's the letter in the alphabet after k? Who knows?
L.
Nice. I always have to, fun fact, I always have to like sing the alphabet in my head. I don't just know off the top of my head.
I should know that. I teach preschool.
Right. I teach high school, I should know that. Okay,
I don't like.
so this time I'm gonna give you 2 functions here.
Oops, sorry about that.
Okay, it's giving you k of t. We're gonna use that function, but I'm gonna give you L of t, and I'm just gonna say t plus 3. Why not? L of t equals t plus 3. So now you have 2 functions. Okay, you're gonna see this written a little bit differently. Okay, but this is how you're gonna see it on your test. K of L of t. Whoa. Okay, it's just a different notation, meaning it's just a different way of writing it, telling us take L of t, right? Take this function, you're plugging it into k of t. You see how it's inside k of t? Everybody see that? L of t is now inside k of t. Okay, well that's all we're doing. We are taking our new function, t of 3, this whole piece, and just like we were plugging things in before, we're gonna take that t of 3 and plug it everywhere we see a t. So again, it's gonna look messy, but I wanna make sure you're familiar with this format right here. Okay, so what this is gonna look like. We have, in k of t, it was negative t cubed. Negative, but instead of t, it's now this whole piece. T plus 3 cubed plus 5 times t, but instead of that t, I'm plugging in t plus 3. Okay, so we literally just took that second function and we plugged it into our first function. Because that's what it told us to do. Take L of t, plug it into k of t. Okay, I'm gonna go ahead, be lazy here since that's a third power. I don't feel like multiplying that out 3 times. Okay, so let's go ahead and just leave this as negative t plus 3 cubed, even though we know it's not fully simplified. That's fine. Let's go ahead and distribute here, though. Let's do a little simplifying, right? What is 5 times t going to turn into?
5t.
5t. And what's 5 times 3 going to turn into? 15. Now, we know that's not fully simplified, but close enough, right? Boom.
You're really lazy today.
You what?
You're really lazy today.
I'm feeling lazy. Well, yeah, I'm feeling lazy, and multiplying it out 3 times, that'll take a good minute, and I don't want to, like, lose you on the main focus, right? Right. Okay. Yes. Okay, so let's do one more. I'm going to change number 10 again. I'm actually going to give you whole new functions, but it'll look a lot like number 9. Okay, so this time, let's take f of x equals 5x squared plus 2x. Okay, so that'll be our f of x first function. I'm literally thinking of these off the top of my head. Okay, we're given a second function, g of x, and I'm gonna say, let's do x plus 1 is my g of x, my second function. Okay, now see who can interpret what I'm gonna ask you to do here. G of f of x. Which one am I plugging in? Which function am I plugging into the other one?
So,
Donovan?
so you plug into C, then into F, and then X.
Very close, okay? Work from the inside out, you guys. Which function am I plugging into the other function?
The X.
X.
Which one, f of x or g of x?
FX.
F of x, I'm plugging into
G.
g of x, okay? So this means I'm taking the entire f of x function and I am plugging it into everywhere I see an x in g of x. You notice you're still doing the same things, taking something, plugging it in. It's just getting a lot more complicated, right? Welcome to junior and senior year of math. Okay, so here's what it's gonna look like. My g of x is x plus 1. But instead of x, we replaced it with our whole function. 5x squared plus 2x now replaces my x, and a plus 1 on the end. Okay, guys, I put parentheses on there just to show us that that whole piece replaced the x. Do I need the parentheses?
No.
No. Are there any like terms I can combine?
No.
No, as well. So let's go ahead and just rewrite it without parentheses, and that'll be our final answer. 5x squared plus 2x plus 1 is our final answer.